Matthew. Yeah,
Hello.
Guys for holding a session in Asia timings. Much appreciated that. Yeah, it's nice because otherwise it's always at 1:30 a.m. for me and it's
yeah.
pretty rough, man.
We've been thinking about what else we could do if we do the course again. A lot of things we'll brainstorm, but I think there are a lot of things we could do to improve it, especially for, and then I think it's even harder. It's hard now for people in Europe. We haven't set up a separate session for them, but they can't really do this one because it's a terrible time for them. And they could sort of do ours, but they could sort of do the North American time, but time zones are hard.
Yeah, it's just like that.
I used to, for events like this, enjoy making predictions like how many people will show up. And I said, like, well, data scientists, what we do is prediction. And so we should be good at it. But now what we do isn't exactly prediction anymore. So it doesn't quite ring the same.
How do you think the whole data science scene is changing since you say that? Can you
Uh,
elaborate on that?
yeah. So I guess there was an extended period of time
Mhm.
where we thought that prediction of either classification or regression, predicting some number, mostly with tabular data or with data that maybe with one text field, then you can make it tabular with like TF-IDF or backwards representation. We thought that those sorts of predictions would be extremely useful or like applicable everywhere. And shortly before LMs came into popularity or before ChatGPT came out, we realized that the breadth of use cases for tabular prediction was like 20% as wide as people once thought. And I was at the time I started a company where I sold Data Robot, and I was looking like what are the use cases we're serving, and we would have these advertisements saying like it's going to revolutionize every business process. But then the things that it was actually used for was churn prediction, lead scoring, demand forecasting, one or two other things. And so you for something that everyone thought was going to be so broadly useful, unless you're at a big tech company where all the decisions need to be made at immense scale and in milliseconds. For most things like human process, if you ran like a grocery store, it turns out machine learning wasn't so widely useful to you. And
Mm.
so I think conventional machine learning started getting less investment on like the Gartner, it was going into that trough even before large language models picked up. Analytics was still broadly useful. And I think now the people who were in machine learning, with conventional machine learning, or prediction, or who would have gone into it, most are working in generative AI in some way. And as a result, we got saved from the lack of career opportunities because we were able to transition. And the other thing that's really amazing to me is that unless you, with some exceptions, the skill set that is required to do AI engineering is actually quite different from the skill set that was required to do feature engineering and actually use like there is some overlap thinking about do I have target leakage in some way or look at your data. But for the most part, like the skills are pretty different. I know actually as data scientists go, I know like a lot of statistics and almost none of that is particularly useful for the projects that we do with generative AI. And so we switched over not because our skills were so transferable, but because people thought they were both AI or ML. And so we got to we got sort of a pass to switch over more easily than I think was probably warranted.
Very interesting.
Yeah, I think that's someone could disagree and I wouldn't think they're crazy, but that's like my current sense.
All right. Should we kick off office hours? I don't know if Dan, you had anything else to. I mean, we just like launched a survey, but I don't know if there's
Oh
anything
yeah.
else we need to call out.
Yeah, so you should have received an email about the survey and then I posted, I think in the general Slack channel, you should have received credits. If you didn't already fill out the form for Modal, I would do that. Charles from Modal is going to come. Modal is, I think, an awesome service. So you should, and $500 is a fair amount of credits. So you should take advantage of that. And like I said in Slack, if you have not if you haven't set up accounts with unstructured or Brain Trust, or I think Llama /Llama Cloud, then do that. And then in about a week, I'm going to ask them to run the credit allocation script again. So you still have a chance to get those credits. I don't think there's any other bookkeeping.
Cool. Yeah. Should we just jump into questions and let's do it? If nobody has questions, maybe we can also just have a conversation on some of the content we've had this past couple of weeks. Has everyone like watched the videos up until this week already, or are most people still on like week 3? Cool. Yeah, I think one of the questions we asked for the breakout rooms was around like what kind of processes could we model for both humans and LLMs. I'm curious for the folks in this call, like have you guys thought about building out routers before? And if so, how often are we actually exposing these APIs to both the language model and to users, for example, right? In the example of like searching blueprints, sometimes if we know the user wants to search images or wants to search proposals or contracts, we don't force them down this natural language path. We allow them to just go into like a contract search tool or an image search tool. And it just so happens that the tool the language model uses is the same tool that the human uses to do some of this search. So I'm really curious to hear some of your thoughts on that.
So I'm hesitant to speak to the details of what I'm working on,
Mhm.
but it's a challenge, right, with respect to both product and the experience designer and everything, because the claim and also the desire for AI systems and things like that is that they will understand the intent and the expected outcomes and accordingly morph into whatever code path is desired. So that's kind of the desire and the intent and how we want to set expectations. However, like we have been dealing with in this course, these things are not perfect yet. And what is that right trade-off to show or ask the user, like any kind of confirmation, like if we have two possible intents, which one should we like just show or ask the user versus let's just go down the most likely intent and have some way to course correct once the answer is generated. Like those are some pretty hard decisions, and it's not just engineering, right? It's also how the UX or how the product wants the product to look and to behave.
Yeah, I definitely agree. I think part of the belief is that, okay, if we have a natural language interface, that is actually going to be preferred by most users. And I'm not, that's something where I don't really have that much data on, right? It's like, I think when we have expert users that know exactly what they want, having to sort of use a natural language description versus just being able to sort of use one of these specific tools, I think that's a matter of like doing a lot of experimentation, right? Like if I want to understand the weather, sometimes I just want to like shout out like Alexa, what's the weather? But other times when I know exactly what I want, I do want to just go open up my weather app, see a 7-day forecast, and understand that this weekend I shouldn't go to the park. I don't really want to have a conversation around that. Do you guys have like a data science team or a product team that does that kind of hypothesis testing, or is it very much the case that like leadership just wants a search box and no other UI, right?
Oh no. So there is a lot of user testing. So we are a big company. So even within our company, we have a lot of kind of different roles and kind of personas that we can go and have these alphas and betas and have people use it and give feedback. So there's definitely that. Also, the kind of questions people are already asking in the field can give a sense of what they are likely to ask should were we to advertise these other kind of features.
Yeah.
And some of the things that don't exist in terms of capabilities, people are already trying to ask. I think you also covered it pretty well in many of your talks. That like people don't know or they shouldn't have to know like what the system is capable of. The system should inform them and educate them what it can or cannot do, and maybe have some guardrails, etc., to make sure they can learn as they use the system. So yeah, so that is the case, but it's an open-ended system. I think the one thing that would be interesting to cover in your course at some point would be how do you deal with multi-language inputs, right? So right now, English itself is a fair amount of usage, but there's other languages, European, but even
Yep.
beyond Latin. How should these systems be built so that because these intent and etc., like it's even hard to judge. Like English logs we can review and get some quick sense of, but like Japanese etc., we can translate of course, but it's just harder to have maybe cultural and all these kind of understanding of how people would ask in their natural language some of these intents. So that's something that is a little bit tricky.
Yeah, I definitely agree. I think one of the if I reframe it as just what are the risks of having bad translation, one thing I've noticed is that if we have prompts that are in English, then there is always some p probability that the responses or like the arguments end up being in English, even if the input data is not in English. Like we have a lot of examples where we have prompts that do like call summarization or extract action items, and if the conversation was just in Turkish, the action items would still be returned in English. I think part of, I mean, most of what we've done so far has just been leaning on the capabilities of something like GPT-4 or potentially some of the Cohere multilingual models. And then as part of the prompting, figure out, okay, what arguments are like some symbols, right? For example, like a filter key, those might just be in English because that's just like the enums that we've used versus actually having to do keyword search or text search in a different language. But when you say like a lack of the cultural side of things, like do you have an example of like what a failure mode could look like?
Yeah, so for example, let's say we have a summarization code path, and I don't know
Yep.
how a person using Japanese would ask for the document to be summarized. So for example, in English, there could be different variations they could use, and we could have them in our test suite and make sure those
Yeah.
are inferred correctly by the router. But with something like Japanese or Chinese or all these other languages coming in, it just becomes a little bit of a wild card how these routers are going to behave when dealing with, I don't know how a Chinese person is going to frame a request to shorten the document or something like that.
Yeah, and this request to shorten is less of like a using a summarized tool, but just having some instructions. Because I definitely know that like
Yes.
just GPT in Chinese apparently has like a very specific tone, right? That like I'm not aware of, but yeah, when I have friends that read that, it definitely is a thing. But yeah, that's definitely going to be a challenge to figure out what kind of training data exists in these language models to do this kind of task. Because yeah, I don't know if I know GPT-4 has like Japanese specific language evals, but yeah, I'm not sure like where OpenAI is spending most of the energy,
Yeah, and
unfortunately.
the other curious fact is that most of these LLMs, like English is obviously the best performing language, and then everything else has a drop off with respect to English. What that drop off it is with respect to intent understanding, etc., is hard to
Yeah.
assess.
Yeah, I think they're just I think if it was summarization specifically, maybe then like we need to have like summarization type evals, which I think Eugene has written a lot about. But for other things like whether it's like router selection or whatnot, those might be a little bit more easier to just sort of segment and again model things
Yeah.
like precision and recall. Any other thoughts on sort of the general split between LLM tools versus also exposing some of these interfaces to downstream consumers, right? Because I think if we look at something like Google, right, Google has yet to avoid using routers that take you to different UIs, right? It's like if you search for an image, if you search for a video, if you search for a product, Google will try to show you product specific interfaces, right? And I think even like given that, it's still the case that when Google tries to then build some kind of natural language text answering system, it's not very good, right? Usually the intent is a lot stronger. If I want to find images, I want to be shown images, and then once they're images, I want to be able to filter for like the created date or the image size, or like by color, right? Because those are sort of like simplifying assumptions that you can use to improve the satisfaction of whatever assets you're trying to show the user.
We have actually done this. So like as I mentioned earlier as well, we have this agent that has like two tools only. One is to create charts and one is to create summary. And we have widened the summarization bit directly into wherever user is seeing feedback. So you can directly ask questions leveraging that tool. And even in that tool, it skips like the filter creation part. So user can directly provide filters from the quantify builder, what we call, or the vector in the UI, and then ask questions. So then we basically bypass the agent plus the actual filter selection that we have and directly summarize using RAG.
In those situations, do you ever use the user interaction data to potentially improve the few shot examples or potentially fine tune the language models? I have one use case where when we have sales emails that are coming inbound, we're able to segment them into multiple search queries and render that to the UI. And then we have the sales team, if they want to improve the search queries, just edit some of the queries. And by doing that, we can basically fine tune like a GPT 3.5 that is 5 times faster and like 5 times cheaper than GPT-4.
We haven't started fine tuning yet. So we are still working around. So right now, the prompts that we give to the user, and these are some of the questions that you get, are still not dynamic in nature. So they don't take into account like what is the context of the query, what is the feedback that you're looking at, and then accordingly adjust to it. So we are first fixing that so that the queries are more that will allow users to actually ask more powerful questions, and then basically start segmenting the type of questions that users are asking. We haven't yet spent time on segmenting, but what we have seen with the chatbot interface itself is the range of questions is quite big. So like the questions are very simple, and then there are like a tail of very long questions that are like very complex and require like a lot of analysis, which the planning can never do. So how do we handle those is like still something that's up in the air.
Yeah, that's definitely that should be a question you ask V2 Anchor from Brain Trust and Zapier. I think they're thinking about doing a lot more planning based systems in their Zapier AI integrations, and so I'm curious what they have to say about that. When I was working with them, it was basically issue of we're trying to do things in a React loop, and it's very hard to get reproducible results.
Yeah.
By building a DAG, the hope is to have much more reliability, much more higher reliability in those systems.
We also went through these loops. Basically, our agent like has been re-architected multiple times. First, it started out with React, then we started to make it more like a DAG. We moved back to React, and again we are using a DAG, and satisfied with it.
What was the limiting factor when it came from going from a DAG back to a React type model?
So we wanted to basically, because we felt that the earlier DAG was not working out well, we wanted to have more interactivity with the user so that they can take corrective actions on top of the steps that we were trying to execute.
I see.
But that the latency trade-off was too high. You could not run with many things in parallel. So that made it so that the complexity became too much.
I see.
And it was
I see.
users were also not really very interactive with the corrective process because they felt that there is too much complexity and too much overload in doing that. So we
I
then
see.
went back, and this was like early before we launched it to a wider set of audience. So just our internal testing, and we felt it wasn't working well. Then the current approach was a DAG, but with a slight reorchestration, with only two tools and not giving it too many options, made it a lot more consistent than before.
That makes sense. Yeah, because I think in the Zapier case, it's like I wouldn't be surprised if like 90% of all Zaps had less than three nodes in the DAG.
Yeah.
Yeah, because one of the goals with producing the DAG was if you can iteratively modify the DAG, then what would happen is, regardless of what kind of conversation you have, there's sort of a final target artifact that you want to produce from that conversation. And if you had that final artifact, you could produce a fine-tuning data set that says, take this entire conversation, summarize it into a single request, and then that summary is assigned to that DAG, right? And then if I want to do few-shotting, I can just basically do search against the summaries and find like 6 different DAGs that look like the one I might care about, right? So if it's like, okay, turn my type form into an email and then add a row to Notion, like there would be like 10 examples of DAGs that do that, and then you could use that. And then ultimately, you can build a fine-tuning data set that says, okay, I have like 6,000 examples of summaries to Zapier DAGs. Now let's fine-tune it, and now we just have a data set to fine-tune against. Does it sound like for your use case, it's like too complex of a DAG, or is it still like 2-3 nodes?
It depends. Like in some cases, it's 2-3 DAGs nodes only. In some cases, it's just one node even. But users can write a very complicated question, like say 10 entities they'll mention. You could feedback from all these 10 things and then provide me an overview. So now there we have even seen like the code breaks because we are running everything asynchronously, and suddenly we're getting SSL timeouts. The connection breaks. We are not able to process the report. So there are like a lot of code challenges around these kinds of very large DAGs that need to be processed that we're trying to handle. And then there are even cases where systems that are downstream start to break if the nodes are too complex, because those systems are written to be basically processing smaller and very granular nodes. But if the nodes become too complex, then those start to break as well.
Yeah, see, because I think our goal is like, if we can produce a single DAG, we can send it to an execution engine, and then that execution engine can handle all the concurrency, that and maybe all the types and all the checking, and then if there's any errors, we just give it back to the language model. But yeah, I can see how if it's very wide fan outs, you might have a lot more like issues.
And what we do is we don't wait for the entire plan to be generated even. So we stream the plan and start execution as soon as we. So that way the latency for the end customer is a lot lower. So we start streaming tips as well to the user. Okay, this is what is happening right now. So that way they don't feel like I'm waiting for the entire plan to be generated.
Yeah, I'm gonna cover that a little bit in week 6. Basically, doing a lot of like streaming planning using partials and iterables. But so I'm curious to hear what you have to say about that. But let's also just jump to a question that Matthew had. Matthew?
Yeah, sorry if this is a stupid question, but by DAG, you guys are referring to, for example, in Zapier, the workflow one, and then it connects to another. And
exactly.
Okay, I see. And as far as routing, is that one of the main implementation paradigms you recommend? Or you mentioned React? Are you talking about like actual React UI stuff, or like?
No. So yeah, let me first define React, which is like React is reason and act.
Okay.
And so the idea is like, let me put in a loop, and so I'm gonna let the language model decide, okay, given where you are and the request, and a set of tools, which tool should I call? Okay, call this tool. This tool return this response. And you put out, given this response and the original goal, what is the next tool I can call? The issue is those aren't guaranteed to terminate. And so if you looked at the like AutoGPT a year ago, you would get a world where I think someone tried to like buy a bicycle and it ran for 7 hours. And what ended up happening was they went back to sleep. They went to sleep. They woke up the next day and it was, oh, I see a JSON parsing error. Let me remake a post request. Oh, I see the JSON, and then it just cost them like $40, right? Whereas if you were to produce a DAG, you effectively, like a directed acyclic graph, you can basically say, this DAG has 6 steps. I'm going to run those 6 steps and get a result. And if that's not the result I want, I've at least terminated, which is one thing. And secondly, with the DAG, you can do a lot of checking, right? And so if there's something that's incorrect in the structure of this call, you can sort of avoid that. But that's almost like routing like plus in my mind, because it's less about tool use and more about structured outputs. But that tends to be a little bit more complex, I would say.
Interesting. And then just one follow-up. Do any of the cloud tools out there, like LlamaIndex or anything, do they push you in one direction or the other in your experience?
So I think for LangChain, they almost do a third thing, which is they define almost like a state machine. So if you look at LangGraph, what they do, and to be fair, like chatbots that use state machines has been around for like a long time. Like I think I used to build a bunch of like Facebook chatbots in like 2016, and they were all state machines. And basically what happens is you would be at a certain node, and at that node, you have a bunch of different edges that you can transition to. And the language model can choose which transition to take. And then you transition to another state. And then from there, you would ask, what is the next transition? And so based on how you build that DAG, like you might always terminate, or you might still have like cycles and whatnot. But that's almost like a third way of building these things, right? One is the language model produces a graph versus there's an agent that has a state machine, and the language model chooses to transitions in that graph. And then there's the React model, which is kind of just like a single node that goes to itself, right? I would say those are kind of the 3 big paradigms. But I think all 3 are valid, right? Like there's this notion of like Bell's paradigm, I forget what the Bell's principle, whatever, which just says that like any existing complex system was derived from an existing complex system. And producing DAGs and using state machines both have like been successful for decades, and so I'm not like leaning one side or the other.
Interesting. Thank you.
Yeah, if you look at the chat, planning tasks is an example, and then if you look at LangGraph is another example. But that said, I'm probably mostly bullish on either using the state machine or producing a DAG. The only benefit to me is I can fine-tune a language model that outputs a DAG, where it's still not clear how I can fine-tune the state machine, right? I don't know if those are like specific enough, but I can try to share my screen and look at some documentation as well if you'd like.
That's good. And then the DAGs are kind of encapsulated, and that's why it makes it easier for an LLM to characterize those for you.
Exactly, because you can say like, here are like the 10 node options, and here are the 6 ed options, and your job is just like play with Legos and plug them together in a way that gets me the final result. And then my system can say, hey, you plug these systems together incorrectly. Right, you're missing an argument, and you can kind of type check this
DAG. And so the error messages of the DAG kind of let the language model know how to fix it. Yeah, so if I show my full screen, like this is kind of a JSON object version of a graph, right? Where I asked the language model, what is the difference between the population of Canada and Jason's home country? And you'll realize, okay, well, to figure that out, I actually need to know what Jason's home country is. Then I need to figure out what the population of Canada is, and then the population of Canada of Jason's home country, and then find the difference, right? Like I can't do a single step of search. And what you can do is you can basically do something like this, where the language model can produce a node, the question for that node, and if it has any dependencies, right? And so here, the population of Jason's home country depends on identifying Jason's home country. And so you can just send this JSON object to some execution engine and just have code figure this out, right? And maybe it's just like, okay, given this, should I do a search or should I ask for like human input? And then you can kind of reduce everything. And the idea is that given any of these, there should be like a correct answer. And that's kind of how you do fine tuning. Whereas if you look at something like line graph, I don't know if there's a good description of it. Here, like this graph, this state machine is defined externally. And then how you transition the state machine is dependent on the language model. And this is how we've like built chatbots for decades. And so I definitely think this is a durable abstraction when it comes to making these agent systems. Yeah, so it started, it's going to reason about the agent, it's going to either do some action and then come back. Like this is basically the React model. The agent takes an action, gets a result, takes an action, gets a result, and eventually terminates. And then obviously I think you can warn that like you might get stuck in this loop and you'll never terminate, but that's more of a computer science thing. But I think with these systems you can build pretty complex agents. Glebov, another question?
Yep. So wanted to ask, have you thought about how can we go about evaluating plans? So like given a question, you got a DAG, but how can we evaluate and then start to improve that? That is something we haven't yet solved. I wanted to hear any thoughts around that.
Man, I don't have any good answers. I think the simplest thing to do is just checking for some notion of correctness in the graph, right? So like a simple example is when I ask a language model to write TypeScript, I run the TypeScript through a type checker, right? And if there's a type error, really, you can think of like the entire code base is this like AST, and if it's a type error, it means like something about the edges was incorrect, right?
Right.
So you can imagine for this JSON plan, I can run some test that just says like, oh, are there any cycles, or is there anything wrong with the structure of the DAG? So those are like some computer science type tests. Outside of that, I'm not fully sure if there's any good literature on how to do this like multi-hop planning. Like I think you can do it in a really simple case where it's like Wikipedia questions or math questions where the answer is easy to evaluate, right?
Yeah.
But if you were to go to like, okay, like, yeah, but I don't know if you had examples where it's like, okay, you're Zapier. Like, I don't know if Zapier has like a super solid system to evaluate, except for the fact that they know when the DAG has an error, right? So one thing you can do is you can type check the DAG, then you can check for cycles, and you can do all your computer science tests. And then the second thing is when you execute the DAG, are there any errors, and where are the errors found, right? If you produce, like, if you're Zapier and like your top 5 most common components are like email, probably Typeform, and like Excel and Notion, you likely have a per node error rate across all the workflows you've ever had the language model generate. In which case you can probably figure out like, okay, like if this is your segmentation, maybe you find that, oh wow, like we are really not doing email well for some reason, right? And if the inputs to this email node is some kind of schema, are we like inputting invalid bodies? Are we inputting invalid emails? And now you can find like not only the node level issues, but potentially like the input field level issues, right? So these are still evaluations on the correctness of the DAG, and some notions of correctness on the execution that still feel very binary, right?
Right.
It's like if you input a date that's invalid, that's an error. But in terms of answer quality, I think that's going to be as challenging as evaluating generation.
And would it make sense to evaluate the steps that the model has given, basically? So like, do them follow a logical consistency, or would following those steps actually get to an answer without looking at the actual execution? because execution itself is like independent of the node creation right now.
Yeah. I think semantically you might be able to use an LLM to check some kind of ordering, but I would also suspect that's going to be very use case specific.
Bias.
'Cause I've only thought about like sending emails and receiving emails
Hmm.
and like when a type form is being submitted, it creates an entity that's passed in emails. Like, what would be an example in your case where you feel like you could test that?
So people ask some questions like, what kind of issues do users face when
Hmm.
we lose a deal, and which competitors are they mentioning leveraging over us instead? Now, this is a very complex question where you need to first identify the competitors, you need to identify the issues, and you need to collate those into a final answer. And you also need to check for that the deal is actually lost. So now the number of things that need to be done are complex, and the model needs to understand, and its reasoning needs to be very solid. Okay, what are the different steps and how do I actually stitch them together to get to the final answer?
I wonder in that example, like how much. And by the way, like I know we're kind of just like jamming on this problem, but if anyone has any other questions, like definitely like raise your hand or have any comments. But yeah, like, I wonder how many of those actually have dependencies.
So sometimes they do, like there are complex dependencies as well. Like you need to identify the competitors, and then for each competitor, do some sort of an analysis. Like, why are
I
we
see.
losing these two? Each competitor, break it down by the competitors. So in that case, you need to first identify that is your first dependency, and then for each of them create new nodes, and those
Yeah.
new nodes basically need to be executed for okay, for this competitor, what
Yeah.
was the feedback? So this kind of decomposition also happens wherein the first node leads to the decomposition of the subsequent nodes. And
Yeah.
in the DAG itself, the model cannot basically predict okay, what were the competitors. So it creates a single node, but then we decompose it based on the
Yeah. Yeah. That's
response.
something that would be hard to figure out using the state machine model because you might assume that like it might terminate. Like that's why I kind of like this idea of producing DAGs because if someone just came up to me with that example, I'll go, oh wow, this is something we don't have a capability for. Let me just
Right.
produce like 10 more examples of questions that look like this and they're correct DAGs. Put them in my like snippet database and check if this actually improves the performance. Like if I had this kind of feedback and it really mattered and it was a capability I cared about, I
Got
would
it.
just sort of
So we
like,
do have a snippet library as well, but we haven't seen that to help out as much as we would like. Like,
yeah,
because maybe the retrieval is not good enough. Could
yeah,
be an issue. So we need to spend more time there. So like Planner was like something we haven't invested in since we rolled out V1. That
yeah.
is something we are thinking about how to improve now since we have solved some of the other burning pains with text to SQL.
Yeah, I would love to test two things, right? One is given a question, can I retrieve that good snippet?
Hmm.
And then the second question I would ask is condition on if the snippet was in there, does it actually improve the likelihood that I generate a correct answer, right?
Right. Makes sense. And if we can
Because
evaluate
if
that
someone came, yeah,
consistently.
yeah, because I definitely agree that it might be the case that we need to have better retrieval on those snippets. But
Hmm.
I think if we could just come up with like 10 examples of going, hey, we have a very similar DAG and a language model just does not look at it, or no matter how much we prompt it, it's still unable to reason about this, then those become sort of like larger fundamental issues with language models capable of. But yeah, just having a number that's like, what is the probability we find the right example? And
Hmm.
then another number which is the condition on that we found the right example and it is in the prompt. Could we generate a successful answer? And just figure out like which number is lower and try to improve it.
Makes sense. So
Yeah.
right now our library has like only 10, 20 samples. It's not a very extensive
Yeah.
library. So I think spending more time expanding it might be worthwhile. That
Yeah,
could
because
basically help us
like
solve
if both
this.
those numbers are like 50%, maybe we just say like, okay, you know what, this is just gonna be really impossible. But if it turns out like one like if for example we find that like okay, if we found the right example, we always get a good answer. Then we
Right.
know we just have to invest in better retrieval. Maybe we fine tune an embedding
Hmm.
model. Maybe this is the energy you need to go, okay, let's go from 20 examples to like 200 examples. Right,
Hmm.
let's cover like every possible different use case for doing churn analysis. I doubt there's 200 different ways of people doing churn analysis, right?
Yeah. Yeah.
I bet there's like 20 that most companies
Yep.
use. Like
That people
like
care
did we
about.
lose people from competitors? There's probably like 20 reasons people sign out. can we systematize each one, make 3 examples for each, and just really figure that out? If we demonstrate that conditioned on having the right snippet, our success probability is like 99% or something. But that's how I would like systematize that a little bit more. Before we go on with that, I think there's a quick question. We built a document assistant that securely stores and helps chat with PDFs. Recently, we have added functionality where the system decides whether to process the entire text of the PDF or use a RAG approach based on the user's query. For example, if a user requests a summary, the full text might be more appropriate. However, maintaining the conversation context for the entire chat history is challenging due to the limited storage capacity. We're seeking an effective way to store and manage the conversation history without overwhelming our storage resources. Additionally, we frequently deal with large PDFs, further complicating storage and processing. Okay, let me think about this for a second. So it's like sometimes we choose to return the full document, other times we choose to return chunks. But the limitation is around. So LangChain has a pretty, again, so I think any solution here really is going to be like a latency versus storage trade-off. What LangChain apps did a while back was do summaries of the current history. And so instead of just having a messages array and then in the middle of that messages array having like 50,000 tokens of a text document, we will ask a language model to summarize some portion of it in such a way where like the last 10 messages is all that's included, and then anything beyond 10 messages is summarized. Right, so there's some notions of like summarization as a way of improving that. There's other prompt libraries like what Cursor uses, where it's like really complex, but it kind of looks like XML, and you can effectively limit the number of tokens per like template variable. And so you can basically what Cursor's like prompting library does is it can dynamically figure out like what should we summarize, how many messages can we include for each message, how long can it be, in such a way where we will want to constrain it to be less than like 50,000 tokens. And so yeah, there's one which is just like, can we just summarize everything and replace the messages with a summary? And the second one is, can we be smarter and more intentional about the limits that we set on some of this context? The other thing too is maybe it's the case that if we answer a question, we can include the summary, but once we're done the summary, we just don't include the full body in the next messages array, right? And if you want to answer another question, we just might have to like inject it back in and pull that out. I don't know, Dan, if you have any other thoughts on this.
Yeah, I have 2 other thoughts. So I think there's a part of this question that I might not understand what the product looks like. If the issue is that someone has a long history, long conversation, because they ask one question about one document and they bring in another question for another document, and ideally what you want them to do is just start a new conversation, adding a little UI widget that says, hey, we are reaching the end of some little UI widget that says basically we're reaching the end of our storage, which is their context window, could be, I think, a quite simple solution. And then to know how many tokens you've used, it would be straightforward. And then if the concern is latency when you have a back and forth, if you're using Claude, this could be a nice place to use the new KV caching of they've uploaded a huge document, and now every time you want to process something, you're going to process. You have a long back and forth. Every time you're going to process something, you need to reprocess a 50,000 token document. They've made it now easy with like an extra argument to just cache the processing of that document. Yeah, and then you wouldn't repay the latency penalty of reading the document every time.
Yeah. I feel like in array cast, we had an issue where by default, everyone messages the same text history. And one of the solutions we prototyped was just like, could we have a tool that says start new thread? And like just by having a simple prompt that's like, call this function if you think the conversation has changed. We'll just like render a modal that says, hey, if you start a new conversation, it's going to be cheaper for you. It's going to be a little bit faster. And we can like organize your conversations, and we just presented the benefits of starting a new conversation. I think that was like 85% accurate with a terrible prompt and some like 20 bad examples. But I don't know if that answered your question. I think, yeah, if you can just follow up with a message that says, okay, like, is it the case that we do want to have everything in the prompt, or is it the case that we should just be pushing the user to change the messages?
Yeah, I think that answered my question. But then again, the concern was that when we summarize the context, we tend to miss out on a lot of information.
Yes.
Yeah, so that's something we are worried about.
I think there's something to be done there, which is figuring out why. Or like, if I just give a 2 hour video, like if I just gave like Claude the first video of this lecture series and just said summarize this, we might get 6 sentences that says like the speaker talks about the importance of having metrics, which is like a correct summary, but maybe it's too short of a summary. And so I think a part of there might be actually just focusing on the summarization prompt and figuring out when we do miss information, what exactly are we losing? Like, what are we not recalling in our summary? Like, Ivan actually did a great post on doing chain of density summarization, where one of the goals of the summarization is to make sure we preserve all named entities. And so what that means is the summarization is incentivized to say, Jason Liu speaks about the importance of techniques 1, 2, and 3 versus the speaker, because Jason Liu is an entity that we want to preserve, right? And so there's some notions of the summarization there where maybe we benefit from saying, preserve all the entities, preserve all the facts. Here are some reasons why we do summarization, if that makes sense.
Yeah, thank you.
I also wonder if you can do something with the UI so that users can express dissatisfaction with an answer that came from RAG, and then you fall back on handling the whole document in those cases.
Yeah, that's something we're thinking about, getting feedback from the user themselves. Yeah, that works.
Yeah, I think one metric that I'm trying to consider pushing out more on is, can we generate some statistics over the chunks and say, for all the chunks that are returned, are they from many documents or few documents, right? Like if we return 10 text chunks and they came from 10 different documents, that's a different statistic than if 10 text chunks came from a single document. Llama Index calls that like small to big, but yeah, I think there's some hierarchical nature of how we can think about some of these things. Like for example, one of the clients I work with that does marketing, we know that pricing documents like pricing questions should just use the entire pricing document rather than trying to do search. Whereas asking about use cases, that's something that we can use chunks for. And we just basically have a classifier in there. Beto asks, anyone know about using Claude caching in prod? Wonder if there's any gotchas. And then Matthew says, I know so the pricing of using the cache is not cheaper than OpenAI for Mini. Maybe the model using the cache content in Cloud is superior, so the cache does not, beyond that cheap, is still justified. I have not experimented too much with the prompt caching. I only know that like you can prompt the system message, cache a system message. But I even remember like seeing prompt caching in Gemini and not being super impressed with it. I don't know. Dan, have you played with prompt caching a little bit? Maybe.
I've done nothing more than read the blog post. Like it conceptually seems like a good idea and like it should work, but I haven't actually tried it.
Ivan, maybe we should come up with some benchmarks for the instructor library and see if anything comes out of that. Yeah, I think in principle it's very useful. But even then, I think, one of the gotchas I know of is that the prompt caching time to live is like short.
5 minutes.
Like 5 minutes. And so like I think it's really just for conversations. Like if you're doing like code development, it might not make sense because you might cache the entire code base, but if you don't make another request in 5 minutes, you like lose the cache. And so there's depending on the use case, it might differ.
I think in the long run, it's not just conversations. I think that they hope that someone's going to have like 100 pages of documents in a production app, and they always want this context to be there. And it's almost like a replacement for some version of RAG. That this is always there. There's always enough traffic that mostly keep it live.
Yeah. I mean, I think I would consider doing that for like the instructor documentation.
Yeah.
We just load it once, and if you have enough traffic, we can do it. Oh, someone has a question. Azil?
Yeah, I'd like to know more about Colbert. So I think Ben was supposed to talk about Colbert.
Yeah.
So when do you suggest to go with those embeddings and then against it, other sort of?
Yeah, I mean, I am not an expert on like interaction models, so I'm not going to say much. But two things. One, Dan, correct me if I'm wrong, but Ben will still present, but on a Wednesday.
Ben is joining us next Wednesday.
Okay, so we'll definitely talk about that. The second thing is, so today, I don't know if you were at the LanceDB talk, but they showed some like closed benchmarks that they're going to open up soon, and the Cohere re-ranker v3 outperforms Colbert. and it outperforms the answer AI. So Cohere v3 outperforms Ben's model. It's all I saw.
Nice.
And so I would use Colbert if your benchmark says Colbert is better. That's like the lazy answer. I think there's other like answers around like how well does it standardize across other infrastructures, right? There might be differences if you have like 1 million vectors versus 30 billion vectors. But yeah, I think for me, I almost never think about the model. Like the model is like an implementation detail. Mostly what I think about is how easy is it to train this model? How much capacity does it have? And what metrics do I care about optimizing for? Yeah, usually to me, the model is just something I have to pick to satisfy other constraints that I have, right? It's like when I was training like vision models, like ResNet 52 outperforms ResNet 34, but ResNet 34 fits nicely on like a cheap EC2 instance and runs on a CPU. So I'm just going to pick that instead. Because these models, well, they're going to change this year, next year. There's going to be V4 and Colbert 5. But like one thing I'll talk a lot about in next week is the fact that your moat as a business is going to be primary, as at least in the re-ranker part, is just going to be about the volume of like triplet data you have that align with business outcomes. And then which model you choose is just, you just find $100 and it'll tell you what the right answer is. Dan, are the videos for Chang's talk live now? I think Matthew was just checking if there's...
Yep, I'm pulling it up. I'm about to put it in the chat.
So is every video automatically uploaded to Maven, or are you sort of doing that manually right now?
No, everything is, there's a little bit of a delay for Zoom to do some processing, but it all is automatically put in Maven.
Okay. Yeah, at the end of the course, I'm gonna like edit everything up and turn them into like I'm gonna turn the guest speaker videos into YouTube videos, and folks can just check those out there. But yeah, I was very surprised that Colbert v3 outperformed Cohere v3 outperformed Colbert. There is a nuance though, I think, which is that Cohere v3 would suppose that you are both using a cosine search first and then using Cohere to rank it. Whereas I think with the Colbert model, you don't need cosine distance, right? Is a single API call. And so I think you benefit a lot from a latency trade-off, right?
So do you need a GPU to run those models, or it runs on CPU as well?
I think those are just latency trade-offs. Like, because I mean, yeah, like this is like a terrible answer because I really don't know if you. I think what that really is saying is like, could you get under 300 milliseconds of latency with a CPU? That I don't know, because the embeddings and doing the brute force calculations I think are two separate tasks. And so yeah, like maybe you rarely need CPUs to do the k nearest neighbor search, but with enough data you might want to use a GPU to do the embedding. And so there's a separation there, right?
And one more thing that was bothering me was like, for Colbert, you need both the question as well as, so how do you retrieve those documents? Is it like you do a vector search on those documents and then give it to the Colbert model, or?
I don't know the full implementation details to give you a good answer. I think that's definitely like an Omar or Ben question.
Got it.
Yeah. But yeah, I think there's just like every query is multiple vectors, and there's like chunk vectors, and then you interact them at the end. And this interaction just basically says that like a vector model is unlikely to ever be able to figure out the difference between I love coffee and I hate coffee, because like they're kind of averaged out of embedding vectors. Whereas cross encoders will be able to detect that if you have training data that suggests that those two are different things. And so the Cohere re-rankers and Colbert both will be able to figure that out. The only difference is, I think the Colbert vector search is a single call that gets you like a single set of results. Whereas with Cohere re-ranker, you're likely going to have to use vector search first to subset it and then do a re-ranking. It's like a small nuance, but again, to me, that's just like precision recall latency for some compute dollars per hour, and I just have to like make a sacrifice. Because obviously I think like re-ranker v3 probably takes like 500 extra milliseconds and costs a couple of cents, a couple like fractions of a cent per comparison. And so there's like real reasons why you still might choose the model with lower performance. I think those constraints are very specific, right? Like you might find that if you can save 300 milliseconds, satisfaction goes up more than the satisfaction that would have gone up if you had like 5% more recall. But unfortunately, those are things we have to A/B test. The other thing I might add, and Dan, I don't know if you know about this too. I don't know if there are like easy ways of hosting Colbert. It's like Quadrant and Vespa have one, but I don't know, like, I don't know if it's like easy to host.
Yeah, I don't know anything about that.
Yeah, like you can't, I know like you can't do that with like ChromaDB. I don't even know if you can use Colbert for LanceDB. So there's other trade-offs of now I have like a full text index, then I have my data storage index, and then I have my vector index. And then you like break a config file, your ETL goes wrong, and all of a sudden there's like 1 million documents in OpenSearch and like 1,000,006 documents in vectors. Like there's a lot of other things you make decisions on. I think Beto had a question first. Aside from latency, if I recall, storage is a concern. I need to catch up on the talks, but if I recall correctly, storage requirements for multi-value vectors are a lot larger. Yeah, this is a great comment that I tried to push Chang to answer in LanceDB, which is that because things like LanceDB have their storage backed on like S3, I think like cost is cheaper, right? And one of the things too is because if you use something like OpenSearch or something like Pinecone, all the data is persisted like in the instance. And so oftentimes to have resilience, you need to then have multiple instances, which means you end up paying like dollars per gigabyte times 3 just to have reliability. And so there's definitely some trade-offs you have to make there as well. Whereas because it's on S3, like you might have a higher cold start when you actually create the instance. So there's a bunch of other trade-offs as well. Generally, I think storage is pretty cheap. I don't think it's like the biggest concern. That said, I think like Pinecone instances will just like instances that would cost you $4 on like TurboPuffer and LanceDB could cost you like hundreds of dollars on Pinecone. Vibov, I feel like I don't know if I'm pronouncing your name correctly, but just let me know. Okay,
that's fine. It's close enough. One more
close enough.
quick call out. So Pinecone has recently released serverless architecture, and you can save the dataset on S3, and then it pulls the data, and you're actually using it. So that problem is not as much. So we are planning to migrate to that for like some of our use cases. So what I wanted to ask.
Yeah. Go on.
I was going to switch topics, so I wanted to say you can complete your thought.
Wait, I don't know if I heard you correctly.
I was going to switch topics, so I wanted to say you can complete your thought.
Oh yeah, I would love to know what your like cost savings are when you go to serverless, because I think I've still heard a lot of complaints, so I'm really curious.
So we are not planning to switch for cost. Actually, we're planning to switch for scaling. So the scaling that the pods allow us is not good enough. So what happens is we have like these firstels, and those backsells like end up throttling the entire system whenever. So that's why we are thinking about serverless, so that it can scale up as our rest of infrastructure, so that we don't get stuck with the low latency for other services.
Makes sense. What was the follow-up question?
So wanted to ask, what are your thoughts around leveraging like out-of-the-box retrieval systems? Like Snowflake has its own Cortex retrieval system, Snowflake Search or something, wherein they do the hybrid search plus re-ranking. And the latency over there is much better than doing it on our side because of the fact that they do it all on the database itself. So that trade-off, how much is it worth to have it on our side compared to just leveraging something out of it?
Yeah, I mean, I like LanceDB and I like Postgres for the same reason that the compute can be closer to the database. Like, I don't really have any sort of big concerns. I haven't gotten to a case yet, except for like title boosting, where I needed so much control that if I was only able to like twist a knob within the database, I could get like much higher performance. Like that has not been the case so far. And so I don't really have much thoughts about it. Like just being able to have hybrid search already is so good. The only instance that was an issue was when I knew many users knew the file names of Google Docs they were searching for, and they would search basically like a one-to-one file name, and we would not be able to find the results until we did full text search explicitly on a normalized version of the file name. Then we were like, okay, can we just like weight the title boost by 2? If that's the case. But outside of that, like I haven't seen any examples where it's like, oh, if I only change like the K parameter in BM25 to be like 7, I would get good results. I haven't seen that. Yeah, like generally I'm not against using frameworks. I think it's just a matter of like speed of development versus control and how big the team is. Like if you're working with like 7 Python developers, it might just be way easier to communicate if you use something like LangChain, Llama Index, because those are some constraints that you can make sure everyone on the team writes code that looks the same.
We struggled with that actually a lot. We didn't want to adopt a frame, we built everything into it. Now it's like there is a lot of tribal knowledge. So It's very difficult for
Exactly.
anyone else to come in and contribute on that.
Yeah, exactly. Like I built the recommendation and search frameworks at Stitch Fix, my previous company, but I kind of did that knowing that like I would, one, be the villain, and two, everything would be my fault. But I at least like worked at the company, right? I think the danger is when you then use frameworks that are like also changing very quickly. It's like hard to blame anyone because you're not even like paying them. So I think it's like, yeah, it's tricky on both ends. Like I think, yeah, like one of my clients uses Llama Index, and like every 8 weeks we take 1 week off to migrate to the newest version of Llama Index, and that is like real cost, right? Or
Yeah.
like a new model will come out, but the Llama Index code has an assert on the model name, and the model name won't be in the assert string, and so we can't test a new model until we upgrade Llama Index. And then all of a sudden we realize like, oh, like this now broke some retriever. And it's like, yeah, like every 6-7 weeks we end up having to migrate code. But that said, this engineering team would not have built their own like RAG framework, right? So there still might be time savings, right? Because now we just have 2 people building out like 6 different retrievers. We plug them in the router and it works.
A lot of the work we had to do was because of the fact that we wanted to communicate as fast to the user.
Exactly.
So we need to plug inside the tool and write a lot of applications of our own, which made it very hard to like figure what to do with Llama Index. Like it has so many layers of abstraction. Now you need to know each layer in order to actually modify the things you need to modify, which was a very big pain for us to start with. It was easier for us to start from scratch.
Yeah, I think, I mean, my belief is any framework should have at most 3 levels of abstraction. Like if you like command click 3 functions, you should be just in like standard library code. Because yeah, I think like for most of these frameworks, it's like it's pretty hard to own the prompts, and it's pretty hard to own the async loop if you know you want to do some kind of like either asynchronous code or multiprocessing. It's like, how do you decide whether or not you want to call your tools in parallel or not, right? Those are or like rate limiting. I think those are like small things that are a little bit harder to reason about. But yeah, Dan, I would be really curious to do a survey on like what frameworks everyone is using and what tools, like, and even languages. I doubt like 90% of the people here are writing Python, let alone from scratch.
A couple ways we can. I'll set up a survey. It'll be super interesting to see.
Yeah. Because I've had more people come to me for help on moving out of frameworks, but it is usually a lot of work, right? But it is something you only do once.
We have been getting pushed back to move to a framework instead, because that was standardized a little bit more.
Yeah. Again, it's like I think it's definitely a grass is greener on the other side thing.
Exactly. So as CTO keeps pushing, you should not have built it yourself. You should leverage something out of the box.
One specific decision I like to look at is whether or not we want custom UI. It is like pretty annoying to prompt. It's pretty hard to control the prompts. And so the more we care about the output format and the shape of the data and how we think about streaming to front ends, I think that's where we get a little bit more complexity than we care about. Like I just remember like wanting to change the word assistant to the word like helper, and this was like 7 abstractions deep, and I was like, oh, okay, I can't figure out how to like rename the name of the assistant. Those are some small challenges that kind of like escalated.
Yeah, we have like a lot of abstractions just for sending data to a front end. So
and those don't get fixed.
Yeah. Makes sense.
I mostly just use server-side events. I know we're at time, but are there any other questions or things you folks wanted to follow up on? Sweet. All right. Please check out the like mid-session survey that Dan sent out. It should be in your emails, you said. And as always, just ask any questions on the Ask Instructor channel, and we'll do our best to answer really quickly. All right. Take care.
Thanks, guys.
Everyone.